to pick up some papers on your way in. There were 4 different sheets. I only picked up 3 because that's all I'm going to need to explain to you. Let's go ahead and start with this page that looks like this. It says 3rd grade science fair information. This is all the information you need to know regarding the basics. There's the dates about when it is due and when it's supposed to be here at school. There's all the steps of the science procedure or the scientific process. Over here you have everything that your child would be graded on. Over here on this side, and down at the bottom, and here's an example project, and you can actually do this project at home, and one of the other papers that you have walks you through the entire process, and that will show you how easy it is. Now, since it's on here, of course you cannot do it on a final display board. The activity we're going to do tonight is also not one that's going to be an option because, well, we're going to do it tonight as a group. So this is about asking a question and figuring out what the answer is based upon this process. I'm guessing some of you have at least some science fair experience somewhere in your background, either for yourself or for a child. Never. Okay, well, there are 2 things that people frequently think of when they think of science fairs. 2 activities. What do you think of? Seth? Volcanoes and?
Solar systems.
And solar systems. Those 2 items are not allowed. The whole purpose of this is asking a question, and it says somewhere on here, or it used to, about no models. I think it was on a different form. I can't find it on here. Models of activities are not an option because it's all about asking a question and developing the love or designing or figuring out a way to solve a question or to answer a question. So this is basically your guideline of everything you need to know about the science fair, the details. Now, I dropped paper. This paper here walks you through the entire process. It's an outline form, and we are actually going to do a project tonight. The parents get to be the kids, and the parents are going to be the ones who are doing all the writing and all the reporting, and it's very pain-free. But the good news is you also get to be the ones who are actually doing the experiment. So when you get to do it, your kids have to sit there and watch, and, well, that's all they get to do, is watch. So you're going to walk through the project. Most of the kids, I believe, have done this project. Some of them may have not, but it is one that's fairly simple for them to do, just to show you how it works. So we're actually going to do a project tonight about involving a nickel, and it involves surface tension, and involves dropping water onto the nickel. So the first thing we're going to have to do to come up with is what we're trying to find out, and how you turn a science activity, because we do science activities all the time, but to turn a science activity into a science fair project that is worth displaying on one of these boards and turning it into something official takes a little bit of tweaking, a little bit of how you look at it. So we're going to ask a question that has the ability to be answered. And it's not just, how does this work, or how can we get this to happen? It's, let's think about it in a scientific way to figure something out. The most important part, or one of the very important parts of this, is that the hypothesis has to include 4 words. And your kids have all heard this before. They've all done at least one project. Some of them have done 2. Is that you need to have starting with the words. Do you know? Do you remember? 2 words. What do you have to start with for your hypothesis? I think. If and then. So it's, I think, if I do this, and you don't do anything yet, then this will happen. Another very important part of doing a science fair project, and again, it's different from doing a science activity, is that if someone picked up your paper when you were done, or if someone looked at their display board and followed through, start to finish, all the way through, they would get maybe not exactly the same answer, but very close. It is repeatable. It's something that can be redone by a different person and be able to achieve the same outcome. So we're going to start by coming up with our purpose and it needs to involve the words of nickel, and I'll tell you what we're actually going to do, and we're going to write down most of the activity before we do anything. Everyone is going to have a nickel and an eyedropper, and you're going to see what many drops of water that you can put on the head of a nickel before the water will overflow off the side. Now, when I explained this to my students, I wasn't clear enough, and one of my students actually wanted it to go on the little guy's head, and once it came off the head and just went over here by his neck or his shoulder, he thought he was done. Oh no, it has to fall off the edge of the nickel. So again, when you're talking about science, you have to be as specific as you possibly can. So our question that we're asking, the purpose, and that's the first line you have there, is needs to include something about water, needs to include something about the head, and of course the nickel itself. Now, confer with your child for just a minute. See if they can help you come up with a good question to ask. Because again, all of your students have been involved in this a little bit. And some of your kids may have even done this exact activity already. Not answering the question yet, we're just asking the question. The question is something along the lines that's going to have to include some of those words. Now, one of the things I try to teach my students is be willing to be wrong. Lots of times, parents and adults are nervous about looking like they really don't know what they're talking about. I don't know what I'm talking about. I feel like I don't know what I'm talking about a lot of the times, and it's about solving that. It's about being willing to take a risk. I want the kids to take a risk. So, do I have a parent who's willing to read me what they're going to write down or what they've already written down? Yes. Parents, kids volunteer their parents.
How many drops of water can you get on the head side of the nickel?
How many drops of water can you get on the head side of the nickel? Okay? We have somebody else who's willing to, yes?
Very similar. How many drops of water can you put on the head side of a nickel before it spills over?
Okay, so do you see what she added to yours to make it more specific? So first we have how many drops of water can you fit on the head of a nickel? And then we added to that by how many drops of water can you fit on the head of a nickel before it spills over? I would add to it. Okay, the next part is after the purpose is to come up with a hypothesis. So the hypothesis again needs to have I think, if, and then included on it. So again, we want to be as specific as we can so that we can explain, so if someone else picked up your paper, they would know exactly what to do. And your hypothesis needs to include those 4 words, I think, if, and then, in addition to including the words water, nickel, and the head, because we're using the head side only. So, see if you can, again, talk to your child, see if they can help you come up with a nice hypothesis sentence to figure out what you should write down. What should your hypothesis be? Came up with a good hypothesis back there?
Yeah.
Okay. Is Dad with you?
Pretty much.
Okay. You told him the answer. Well, that's kind of cheating. You're supposed to be helping him without actually doing it for him. You think he'd be willing to read it for us? Okay.
I think if 30 drops of water are slowly dropped onto the nickel, then it will spill over.
I think that if I drop 30 drops of water onto the nickel, then it will spill over.
That's not
Pretty
what
cool.
I did.
That's not what you told him. So, but he has the idea down. He has water, he has the head and the nickel, and then he has his I think, if, and then. So he has the important parts there, and he told you what he thought would be there as well. So I think that is just fine. You have all the important parts. What about you? Would you be willing to read what you have?
I think if I put 15 drops of water on the nickel, then it will overflow.
I think that if I put 15 drops of water on the nickel, then it will overflow. Sounds like a beautiful hypothesis. You're being specific. Now, one of the things I had the kids do, because I like to be very specific with the kids, is that as you're going to do it, are you going to drop them from up here? Or are you going to try to drop them from down here? So I add words like from very close to it, so that they know. Like for most adults, it's going to be common sense that if you want to get as many as you can, you're going to come very close. You know, but scientifically, it's good to add those kinds of details as well. But what you have is just fine for what we're doing here. Right now, we're just trying to understand the process. Okay, the next part, I believe, is probably the simplest part. You can't have that. It's your mother's homework tonight, not yours. The next part is to come up with the materials, which I believe is probably the simplest things. You're going to need 3 things. A dropper, a nickel, and a cup of water. Now Now we are actually going to write down the procedure, and then we're going to move the papers out of the way, and we're going to pass out the supplies for you to actually do this. There, I believe, are 4 or 5 steps to this, depending upon how many details you do. Now again, the kids, some of them have a heads up because they've done this before. Has your teacher done this activity with you yet? No. Not yet, so she'll be tonight as well. Okay, what is the first step? You're going to have these 3 items in front of you. What's the first thing you're going to have to do? Yes?
Fill the dropper with water.
Fill the dropper with water. Now the first time I said this, I just said fill the dropper. But we need to know exactly what are we filling the dropper with. With water. I didn't tell them what to fill the dropper with, and you never know. Maybe they're filling it with milk, or maybe they're filling it with blood, or maybe they're filling it with lemonade. I don't know. So you need to be specific that you're filling it with water. Okay? Second step. What are you going to do? You just know all the answers tonight, don't you? What are you going to do?
From very closely drop the water on the nickel.
From very close, drop the water on the nickel. What side of the nickel? The head of the nickel. Well, all your supplies are going to be on the table in front of you. Now, again, that's a very good point because one of my students, come on in, one of my students was confused and she decided she was going to hold the nickel while she was putting the water on it. And did it work very well? Not so much really. So, everyone should have, fill the dropper with water, slowly drop the water onto the nickel, step 2. So what would step 3 be? Yes.
Continue until water spills off the edge.
Continue until water spills off the edge. She was paying attention in class. So you're going to continue dropping. You can be more specific. Hi, come on in. You can be more specific. Continue dropping water until the water spills off the edge of the nickel. The word I like for watching. Fancy scientific word?
Observe.
Observe. Observe. So on the 4th, you're going to have to observe. And, of course, it makes sense to count them as you're doing that. But depending upon who's doing this, you may want to add that into your details of your procedure to count the drops as they come out. Go ahead and move your papers out of the way because that's the end of your procedure. That's what you're doing. That is the extent of what you're going to be doing. Now, I would like to know, offhand, what are some of the guesses or the hypothesis? How many drops of water did you think would happen? Now, did you help her hypothesize? Or did she come up on her own? Okay, she should have come up with it on her own. Did you guess 13? Guess 13. Okay, how many did you guess? 15. Do you have a guess back there?
We had 7.
7 as your guess. 30? Okay, yes, I heard yours. 14? Oh, 40. And how many did you guys think? 40? And what did you guys guess? 30. Okay, so that's our guess. The other night when I did this and the kids hadn't done the activity yet, my guesses were around 3, 5, 7. I think the highest guess I had was about 13 was the highest guess. Some of the kids are giving it away because, well, they've done the activity. So Mrs. Barr is passing out that. I have some eyedroppers I'm going to pass around. Everyone has their supplies. Again, kids, you're not doing the writing, you don't get to do the playing. So parents are going to go ahead, and it's very important that if you have your feet on the bottom of the table, you might want to take them off. If you have your elbows on the table, you might want to take them off because any slight jiggle you do could affect your results. If you sneeze, it might affect your results. So go ahead and start following your procedure. That should be glued to the back. Every piece of information that you put on that paper goes on here in organized format. I'm a no. Who cares? I'm going to tell you how to do it.
We're here for 3rd grade.
Right.
So we're going to do
It's not about being right or wrong.
I wasn't right.
Had 69, an individual, and they were on the cafeteria benches. Mercedes did it in class yesterday, day before? Yesterday, and she got 124 drops.
I think it depends on how
part just spoonful?
It is. It depends on how large your drop is. 42. It depends. So part of it is on how large your drop is. Part of it is how close you hold it to it. So I mean, it's just it could be the issue with the exact size of the hole in the end of your dropper. Could be the angle. I mean, these are lots of different variables that go into it. The highest number I've ever seen is actually 150. And I've actually seen, you know, I didn't necessarily watch every single count, but now if you were up into the junior high or the high school, you would have to get into the whole concept of surface tension, why it's doing that and all this. The third grade, we're just about asking a question and answering it. That's going through the scientific process to answer the question. Okay, so if your spots are